Hello and welcome to this repair tutorial, and today we're going to look at a Kenwood and the model number is A-62. This amplifier was manufactured around 1988 and formed part of a stack system, so you would have had a record player with a moving magnet type cartridge, cassette deck, tuner, graphic equalizer, etc. And then in terms of specifications, we're looking at an RMS power output of 40 watts per channel, 2x 8 ohm speakers with a frequency response of 20 Hz to 20 kHz. And then total harmonic distortion comes in at 0.5%. And then for your input sensitivity for your phono stage, it's 2.5 millivolts, 47 kiloohms. And then for your line inputs, it's at 150 millivolts, and that's for your tuner, aux, tape, CD. And then you can also select from the front direct mode, so this bypasses the tone control circuits for the CD and for the DAT. You also have separate controls for your bass, treble and balance, and a 1/4 inch jack socket for private listening using headphones. Now the amplifier is fully microprocessor based, so not only can you do the necessary input selection, but you can also, if you wish, operate the volume control potentiometer, and there's a motor at the rear and a motor control unit. And then in terms of dimensions, you're looking at 360 millimeters wide by 371 depth and an overall height of 127 millimeters. And the amplifier weighs 6.7 kilograms. Now before we get into the issue with this amplifier, what I'm showing you is the rear. And the reason for that, and I've put a circle around two sets of RCA phono type socket inputs. This is where it's marked up as adapter. And the reason why I'm mentioning that is that when the amplifier is bought new, normally in the accessory kit, you should have two links. And that enables you to bridge these two connections. Now, when I receive the amplifier, of course, then I'm not going to have the links. And the importance here is that you do need to install them for test and fault finding purposes. If you don't install the links, what you'll find is that only the CD, when you select direct mode, will have any volume to it. If you select any of the other inputs, then you won't. And that's because the preamplifier is not connecting directly then to the power output stage of the amp. The reason why I mention this and why it's important is you may see the same type of inputs where it'll say preamp out to power amp in, and again links can be missing. You see often on Technics amplifiers, and then of course also this amplifier here. And you may be led to think that it is a fault, but it is not. You just need to find some links and then install them. So let's talk for a moment about what the issue was with this amplifier when it came in. Well, the report was that you had a rustling sound on the right channel, and during test phase, if you depowered the amplifier for a few minutes, sometimes if you powered it back up, the rustling sound may not be immediate, but it tended to just increase over probably about a minute and a half. And then if you operated the volume control, then the rustling sound would be amplified. So that gives you an indication that the sound or the issue is being generated from an earlier stage within the amplifier. And then here from this photograph, what I've done is I've put two circles around two multi-pin ICs, and these are manufactured by Toshiba. So what they receive is a coded pulse from the microcontroller when the operation selects maybe from the remote or the operation is from the front panel. And then the IC will then select the desired input. Now the ICs are not identical, so that's important to note that if you're looking to replace one of them, the part number is different. So when we look here on the right hand side, the first IC marked on the board, IC3, is a TC9163N, but the one on the left is a TC9164N. And then what you can also see is these two grey cables, and the one on the right hand side where I've put an arrow, that is where the input signal comes out of the input selection IC and then goes off then to the volume control potentiometer. And then the one that's coming back, that's after the tone control circuits if you haven't deselected them from the front, and then that's going back onto the board and then into the preamplifier, which is just on the left hand side. But I'll sort of give you another photograph later on where you can see that in more detail. Now the reason why I'm pointing to the arrow and the importance of that is you can unplug it and then you can then check on the pins. So you can have left, right, and then the center pin will be ground. And what I use is an audio signal tracer, which I'll show you in a moment, just to do the fault finding. reading. Now, it's not uncommon that you can have issues with these input selection ICs if they fail, and you could have a typical kind of fault that we're seeing here with this rustling sound. Now, what you are able to do is, of course, check the input signal into the selection IC, but again, it depends how it's failed. So what I'm showing you here is really to isolate the fault, to try and find out, is it the IC or is it coming from something before the IC? So I've just removed it, and then here what you can now see is a circle around the multi-pin connector. And as I said, you've got the left, the right and the ground. So what I'm doing here is I can connect my audio signal tracer, ground connection to the speaker terminal, and then using the probe I just click onto there, adjust the volume on the signal tracer, and I can hear the same crackling sound. And then what I've isolated is that the noise is not coming from the input selection ICs. What I need to focus on, and what you see here, are the input selection components. And really they are resistors, ceramic disc capacitors, and the value of those are 220 picofarad. And then you can also see these other components which look orange with a yellow band around, and those are signal diodes. And the diodes are 1SS133, and they're just high frequency switching silicon diodes. But for this application there's nothing special. So if you don't have that one in stock, or you're looking to source more of a generic replacement, then you can purchase a 1N4148, which is a very common signal diode, and use them as an appropriate replacement. Now, when you hear this type of noise, it can sometimes be generated from maybe one of the ceramic disc capacitors if they're starting to break down. Then maybe they become noisy, but that really would have been a secondary step. Based on experience and many decades of repairing electronic equipment, the area which I focus on first of all are these signal diodes. And what you can find is that the signal diode, the junction internally, starts to break down, and then you get this crackling or rustling sound. And this could be common not just for a diode but any other component. So it could be, as we said, a capacitor. It may also be a transistor, MOSFET. Anything like that can create this electrical noise. Now, if we focus in on the extract from the circuit schematic, just before we sort of look at that, on the right hand side I've just put a photograph of the MFJ signal tracer that I use. And again, they're commercially available, but this can be both a tone generator as well as a signal tracer, and you have the ability to adjust the volume control. And it's a really useful tool to have in the workshop, but this will save you a lot of time when you're tracing signals through. I have an oscilloscope, of course, but when you have these sort of crackling noises, often it's better to trace it with an audio signal tracer. Trying to see that crackling noise on the scope, a little bit more difficult. So here when we look at the circuit schematic, you can see on the left hand side I've just done an extract of it, so not the entire circuit diagram, just so you can see some magnification. And what I'm pointing to here are those signal diodes. Now there are 10 signal diodes for the right channel and the equivalent then for the left channel, but for each input there are 2 diodes. So here I'm pointing to diode D14, but there's also D16. Now, to try and isolate to a single diode would be time consuming, and the reason why is that the electrical circuit that you're seeing here is designed such that there are common rails which then go off to the input selection IC, IC3. So any of those diodes could be generating the noise, and I could remove each diode individually and replace it, and then power up the amplifier and do another check. But as I said, that's time consuming. So what is a very common practice is we use what we term as a block change method. So I will take 10 brand new signal diodes, as we did here, and we just block change all of them at the same time. And then what you then found is that once the diodes have been replaced and you powered the amplifier up into test phase, there was no rustling sound, no noise whatsoever. So we knew straight away that that was the issue and what needed to be done then to rectify it. And then here on this photograph, what you can see is a zoomed in view, and I've just circled one of the signal diodes. But as I said, there are 9 other diodes for all of the different inputs. So not very complicated. Now, if the issue still remained, then the focus area then would be on the ceramic disc capacitors. But as I said earlier, it's more common that in this circuit arrangement that the silicon diodes would be the area that you would focus on first. And you just got it in screenshot, just on the lower left to the right, you can see that the input selection IC has been reinstalled. Now, this amplifier doesn't have a speaker protection circuit. What it does have is a power startup circuit, and of course the protection system, if it detected maybe an overvoltage situation, then the microprocessor would then operate and it will de-energize the startup relay. Now the startup relay energizes very, very quickly. When you first apply power, probably in less than 2 seconds, you'll hear this relay change over. And the reason why I'm highlighting it is, if the amplifier is from 1988, you can imagine how many times that relay is energized and provided power then to the main power stage of the amplifier. So as a matter of course, I simply replace that relay. And then here, there's more of a detailed view. So here you can see on the right hand side is the smaller startup transformer, which is providing, of course, the AC power from the mains. It is then regulated after rectification and smoothing, and then you then have the signal going directly to the microcontroller. And then you can just about catch just towards the rear one of the protection fuses. This photograph now shows you the preamplifier board, and you can see it plugs into the main board. So these are all discrete components. So what they've not done is used an operational amplifier. You can see the individual signal transistors. I've mentioned this often on many tutorial repair videos. If you did have a high DC offset on the output of an amplifier, sometimes of course it could be that you have a short circuit and that's what's causing it, or maybe a bias situation. But what you will find is that these discrete pairs of transistors are matched from a gain point of view, and you can find that signal transistors change their HFE or gain over time, and that could be producing either a positive or negative higher DC offset than what would be normally the case. And then here what we're showing you is the main amplifier board, and of course you also have the multi-pin connector where the preamp board connects. And what I'm doing is I'm just doing a scan of the solder connections. As with all tutorials, it's very important to do this work. Electronic components produce heat. Areas like the power supply, or where you have mechanical stress like the input phono sockets around the transformer, smoothing capacitors, you will start to see a breakdown of the solder connection. So it becomes like a dull grey, and if you look in details you'll see sometimes a small little crack around the solder. So what you do of course is you've not got any power applied, and you reflow any of these resistors, capacitors, input terminals to ensure that if the amplifier goes back into service, you're not going to maybe get a return repair because it's due to a dry solder joint. And then what I'm showing you here is with the front metal fascia removed. And the reason for that is to provide insight as part of this repair video, but also as well to highlight some of the components that you see. Now the reason why I removed this main board is that of course there's solder connections on the back. So I just want to verify that there's no dry solder joints. Also the IR, which is just in view, just on the left hand side, just above the headphone socket, that just gets cleaned off because it gets covered in dust. So you make sure that the IR command gets through, at the correct signal strength. And then what I've also done as well is I've just circled around the microcontroller, and we'll look in a little bit more detail in a moment. And then what you can then see on the right hand side is you have the volume control potentiometer, and the knob has been removed. And what you have is an LED, which is a nice feature, and when the amplifier is powered up you have this red LED which illuminates. It gives that air quality. You can see also the individual potentiometers for your bass, balance and treble controls, and then you also have the DAT and CD direct switches, and then the individual input selection switches. And you can just make out just from the board the multi-pin ribbon connector which connects onto the main amp. And then if we focus in depth, you can see here the Sony device. So this is a microcontroller, and as I said, this is around 1988. Now many amplifiers of this era were not using any form of electronic switching at all, and often the amplifiers were not microprocessor based. So this tells you really that Kenwood was bringing to the market probably more leading edge, I would say, and it's great to see these microcontrollers in there. But of course if there was an issue with a microcontroller, it would be very difficult at this point in time to try and source them. As you see, this is an amplifier made by Kenwood, and it's a Sony microcontroller which is used, and it would have the firmware embedded into there for the control of this amplifier. Just above you can see the individual LEDs again, which would then illuminate. What is a little bit odd, and I've sort of picked this up on here, is that if you press the CD direct mode and then the DAT mode, what I've circled, these are filament lamps, which is a little bit unusual considering that you've got the individual LEDs, which are solid state devices. You have these filament lamps then just with a filter, it's like a sleeve that goes over just to illuminate. So yeah, it's sort of nice to see that, but thankfully in this case these filament lamps were fine and they illuminated and the filament hadn't gone open circuit. Now, as part of the repair, and this is always done, what I'm highlighting now is the volume control potentiometer, and it's very easy to get access to it. So you just remove the locking nut from the metal bezel. If you look from the right hand side, you don't see the access port on the potentiometer, but if you go from the left hand side, you can see the open area. So you're going to spray into there a high quality contact cleaner, or in my case De-Oxit. Just leave it there maybe for a couple of minutes, and then it's a case of just rotating backwards and forwards the volume control pot, and what will happen is that the wiper will clean off with the De-Oxit any dirt which is on the carbon tracks. And there was some, even at low volume, if you operated it, you could get a bit of a scratchy sound, but once the pot was cleaned, completely noise free. And then it's really just a case of just reassembling, putting the bezel back on, and then connecting the multi-pin connectors. Now, really the final part of this, because we'd verified that the rustling sound had been fixed, we'd done all the necessary dry joint checking, startup relay replacement, and also verification on the tone board, and then also the micro LED indication board. We now have to set the bias for the amplifier. And what you see here is really a zoomed out shot, and you can see that the power output transistors are mounted onto the heatsink. That white substance there is heat transfer compound, so it just enables the heat from the power transistors just to transfer the heat efficiently through to the heatsink, and you can see the fins of the heatsink then to take the heat away via the top vents. And then if we zoom in, what you can now see are the large emitter resistors, and they're just in front of the output transistors. You can just make out the driver transistors, and then on the left hand side you can see that there is a bridge rectifier, and then the larger electrolytic capacitors for the power supply for the main power amplifier, and then the two ribbon connectors which are coming in from the microboard at the front. Now, on these emitter resistors, what you can see is that the component leads go through, and that enables you then to clip on to the top of the emitter resistors your multimeter leads. And what I'm showing here is the left hand channel, and these are dual emitter resistors, so that means that there are two resistors inside the single package, and these are 5 watt emitter resistors. Now, for the bias adjustment here, what you have to do is you have to power up the amplifier with no signal input connected. There would be no speakers connected, and then you wait for about 15 to 20 minutes just for thermal stability and for the amplifier to warm through. Your user controls are at midpoint, and then you're going to adjust the preset potentiometers, which I've just drawn a circle around them. You can just make them out just where the negative lead is. You can see the preset on the left and then on the right. Now, as I've said many times before you make the adjustment, you can spray contact cleaner or De-Oxit into the preset potentiometer, and then you can just rotate it backwards and forwards and then just return it back to its original position. It doesn't have to be exact, but roughly the same position, and that will clean the track. So here what we have to do is we have to adjust that preset value until you are reading 18 millivolts across the emitter resistors. So that's both for the left hand channel and then for the right. Now remember, there is some tolerance, so it's not going to be exactly 18.00. You're going to have some level of tolerance there, but you should be able to get it to approximate level. And then of course the other thing to check on this amplifier was the DC offset on the speaker terminals, because it doesn't have a speaker protection relay, and there was no issue at all. It's only around a few millivolts, so I didn't have to go in and start fault finding the preamp board. So really that sort of brings us to the end of this repair tutorial, and what I can show you here is the 10 individual signal diodes. And then, as with all repairs in the workshop, the amplifier underwent an extensive test just to make sure that the fault wasn't intermittent and that it would show up after maybe 1 or 2 hours of operation. I do like Kenwood equipment. It's a pleasure to work on this amp particularly because of its modular construction, the ability just to get access to all the key components. And then also as well, what I would say is the board layout is also very good. And what I'm alluding to is the electrolytic capacitors are not mounted adjacent to power components. So you don't see one of the electrolytics mounted right next to a voltage regulator. And that helps the amplifier tremendously over time, because if you have an electrolytic next to a component dissipating a lot of heat, then it will reduce the operational life of the capacitor, because it will start to dry out, and then you'll have ripple or noise, or maybe if it's a large electrolytic capacitor in the power output stage, then the capacitor reservoir would not be able to provide that. So it could lead to distortion, or maybe a failure then to reproduce high quality quality audio. But what you find here for the capacitors, for the large electrolytics, they are high quality. So the smaller signal electrolytics are all Rubicon, again a high quality brand. So I really appreciate you stopping by, and again, if you require any help, support or guidance, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to provide any guidance or assistance that you may require. So until the next time, I wish you all the very best. Cheers and bye bye.